All right, let's talk about deep learning. You've probably heard this term thrown around everywhere, right? From your smartphone to those self-driving cars we keep hearing about. It sounds super technical, maybe even a little intimidating. But what if I told you it's all built on an idea you already get, like completely? The idea of teaching. So today we're going to break down exactly how machines learn. Let's get into it.
And right there, that's the absolute key to all of this. The main goal? It's basically to mimic the human brain. We're trying to build a system that learns just like we do. So don't think of it like old school programming, with a bunch of strict if-then rules. Instead, picture teaching a toddler. You're not programming them, you're guiding them with examples, experience, and lots of little corrections along the way. Honestly, this one idea, it's the foundation for everything else we're going to talk about.
Okay, so here's the game plan for today. We're going to start with the big picture, the whole AI universe. Then we'll zoom way in to meet the humble little neuron. From there, we'll see how these things actually learn in a big feedback loop. Check out the teacher's toolkit they use to get smarter. And finally, we'll answer the big question: why is all of this happening right now? All right, first up, the AI universe. Before we can really get what deep learning is, we kind of have to figure out where it fits in the whole tech landscape. It's not its own little island, it's actually part of a much bigger family. So at the very top, the biggest circle, you've got artificial intelligence, or AI. This is the huge, broad idea of making machines or apps that can do tasks on their own, without a person needing to step in every time. You see it all the time, right? When Netflix just knows what show you want to binge next, or when your music app creates the perfect playlist, that's AI. It's a system making its own calls to get something done. Okay, so if AI is the whole universe, let's zoom in a bit. Inside that universe, we find machine learning. Now, machine learning isn't trying to create a general thinking machine. It's a specific method for achieving AI. It's all about using, a ton of math and statistics to let a computer sift through massive amounts of data, spot patterns humans might miss, and then make predictions based on those patterns. It's a powerful way to do AI.
And that brings us right here to the star of our show, deep learning. Deep learning is a type of machine learning. It's a subset. So what's its secret sauce? It uses these incredibly complex structures called neural networks, which have tons and tons of layers. That's where the deep comes from. And it's this deep, multi-layered setup that lets it get so close to mimicking a human brain and finding really tricky, complex patterns that older machine learning methods just couldn't handle.
Okay, so deep learning uses neural networks. But what is a neural network, really? Well, it's made of something pretty simple, actually. It all comes down to one tiny fundamental building block, the artificial neuron. Let's meet one and see how it ticks. Let's use a super simple example. Say we want to predict if a student is going to pass or fail a big exam. We've got 3 bits of info about them. We'll call these our inputs. How many hours did they study? How many hours did they play video games? And how many hours did they sleep? We're going to take these 3 numbers and feed them into our single tiny neuron. So what does this little neuron do? It's basically a 2-step process. First, it looks at each input, study hours, play hours, sleep hours, and gives each one an importance score. We call this a weight, like maybe study hours is really important, so it gets a high weight. Then it just adds all that up. The second step is called activation. Based on that final score, the neuron makes a simple decision, yes or no. Do I fire a signal or do I stay quiet? And here's the secret to the whole thing. Learning is just the process of the network figuring out the perfect weights to use. But, of course, the real magic isn't what one neuron can do. It's what millions of them, all layered together, can do. They learn from their mistakes over and over through this constant feedback loop. This is where the actual learning in deep learning happens. It's pretty cool. So this whole learning thing is a 2-part dance. The first part is called forward propagation. That sounds fancy, but it just means the network is making a guess. It takes our students' data, sends it forward through all those layers of neurons, and spits out a prediction. Let's say it guesses pass. Then comes the really crucial part, backward propagation. The network compares its guess to the real answer. Uh-oh, the student actually failed. It figures out how wrong it was, the error, and sends a message backwards through the whole network, basically telling every single neuron, hey, tweak your weights a little bit so we do better next time. And honestly, this quote just nails the analogy perfectly. Think about teaching a baby to talk. You don't just say papa one time and expect them to get it, right? No way. You say it over and over and over again, and every single time, that baby's brain is making a guess, hearing the sound you make, and making tiny, tiny adjustments inside. It's training its own little neural network. That is exactly what's happening inside the computer.
And there's actually a word for this in deep learning. One full loop, making a guess and then learning from the mistake, that's called an epoch. And a real model isn't trained with just one epoch. Oh no, it's trained over hundreds, maybe thousands, sometimes millions of epochs. With every single repetition, it gets just a little bit smarter, just like that baby finally saying Papa for the first time.
So we know the network adjusts its weights to get better. But how? How does it know how to adjust them? Well, it uses a couple of really important mathematical tools to guide the whole process. Think of it like a teacher's toolkit for grading a test and then telling you what to study.
So yeah, that's the big question, isn't it? How does the network even know it's wrong, and how does it actually get better? To answer that, we need to understand two more key ideas.
First up is something called the loss function. The easiest way to think about this is that it's the test score. After the network makes its prediction, the loss function looks at the right answer and basically calculates how far off the guess was. It spits out a number, and if that number is huge, the network was way off. If the number is tiny, it was pretty close. The entire goal of the whole training process is to get that loss number as close to 0 as possible.
Okay, so if the loss function gives you the grade on the test, the optimizer is what tells you what to study for the retest. It takes that loss score, that how wrong were we number, and uses some clever math to figure out precisely how to adjust all those thousands of little weights during backpropagation. It's the engine that actually drives the learning, making all those tiny, smart changes that add up over time to make the network way more accurate.
Now here's something that might blow your mind. The basic ideas behind all this, neural networks, they've actually been around since like the 1950s. Seriously. So why is it suddenly everywhere now? What changed? Well, it turns out it took a perfect storm of two huge developments for deep learning to finally have its moment. First thing, the data explosion. Around the mid-2000s, with Facebook and YouTube and the whole social web taking off, we suddenly had more data than we knew what to do with. Billions of photos, endless text, all of it. And these neural networks, they are hungry. They need mountains of examples to learn from, and for the first time, we could finally feed them. The second piece of the puzzle was hardware. Around 2013, powerful computer chips called GPUs, the same things that make your video games look amazing, got super powerful and way cheaper. And it just so happens they're perfect for the kind of math deep learning needs.
So you see, it was that magical combination, right? Big data and powerful hardware. We finally had both the fuel, all that data, and the engine, all that computing power at the exact same time. And that's what took deep learning from being a cool idea in a research paper to a technology that is literally changing our world. This is why AI isn't science fiction anymore. It's here, and it's shaping everything.
And that brings us right back to the beginning. We're teaching machines by having them mimic the way we learn, the way a child learns, through tons of examples, lots of repetition, and by slowly getting better from their mistakes. It's an unbelievably powerful way to solve problems. But it does leave you with a pretty big question to think about, doesn't it? If we're really building machines on the blueprint of a learning child, what are the limits? Where does this journey actually end?